Do you want to know more about writing software starting from scratch with a bare metal microcontroller? How to parse schematics, datasheets, write drivers for peripherals like UART, I2C, GPIO, ADC and more? Well, then you've come to the right place. So throw away the Arduino and put on the big boy pants and let's get started.
Hello and welcome back to Artful Bytes. My name is Niklas and I'm an embedded systems engineer, and on this channel I make practical videos about embedded systems. In this video I'm introducing a project that I'm focusing on over a series of upcoming videos, and that project is this thing right here, a sumobot or a sumo robot, which is a embedded systems project that I recently built, and I thought it would be a good idea to use this as a launching point for my new YouTube channel. A sumobot is, as the name suggests, a sumo wrestler, but in robotics form. It's made to compete in a competition called Robotic Sumo, and the competition rules for Robotic Sumo are simple. Two of these robots are put in a ring, and the one that pushes out the other one first wins. The main challenge is that the robot has to be autonomous, which means that it has to use sensors to detect the opponent and to make sure it doesn't drive out of the platform. And there are several weight classes you can compete in. The one I built here is in the mini class, which means it can't be larger than 10 by 10 centimeters or above 500 grams, which means it's quite a small robot. Overall, I think a sumobot is a good project for getting started with electronics, robotics or embedded systems. It's flexible in terms of how complicated you make it. You can buy pre-made parts and use an Arduino and throw something together in a day or two, or you can design things from scratch, more as I've done here. Design your own PCB, put on a microcontroller and write the code from scratch and make it into a more well-rounded embedded project. And the competition aspect just gives some extra direction and motivation, which is great when getting started with this kind of stuff. In the series of videos I'm going to make, we are primarily going to focus on writing software. So I'm not going to go into details about how to design a PCB like this or how to make a mechanical design like this. But since this is an embedded system and we're going to do embedded system programming, we must understand the hardware. So I am going to go through the system design and explain the individual parts that we're going to program. But overall, the main focus is going to be on programming a complete embedded systems project in the programming language C. It's going to be bare metal. We're going to start with an empty microcontroller and write all the drivers we need from the beginning. It's going to be hands-on. We're going to be using tools like an oscilloscope, logic analyzer, multimeter. We're going to read schematics, datasheets, all that stuff. So the overall structure of this video series is going to be that in the first few videos I'm going to talk about the hardware in an overview fashion. I'm going to sketch out a block diagram, talk about the individual parts and go over the schematic and PCB design. Then I'm gonna do a quick video where I talk a bit about my development environment and tools. This is maybe not strictly necessary, but I will do a few things from the command line, so I think it's a good idea to have an understanding of the setup. Then we're gonna do lots of videos on writing individual drivers, including GPIO, UART, PWM, I2C and so on. For this, I'm actually going to be using the evaluation board for the microcontroller, the MSP430 launchpad, just to make these videos a bit more isolated and general. It also gives you the opportunity to follow along if you have the evaluation board yourself. Once the drivers are in place, we transition to the actual PCB and start bringing stuff together. Here we get the code to a point where we can control the robot with a remote control. And at last, we developed the code to make the robot autonomous, which we do by designing and implementing a state machine. At this stage, we will also do a bit of simulation using a 2D simulator that I built. I'm really looking forward to making this series of videos. And even if you're not interested in building a sumobot in particular, most of what I'm going to do here is applicable to any embedded system. And since these are my first YouTube videos, I really appreciate any feedback, questions or suggestions. Just post them in the comments below.